we've got another beam or hanging rod question. So a beam AB has weight W newtons. So first let's make a beam that is AB and its weight is W newtons. Length is 4 meters. Do we know it is uniform? Yes, it is a uniform rod. So that means we can have W. This is 2 meters. This is 2 meters because it is a uniform rod. The beam is held in equilibrium by 2 vertical ropes. So one is having tension TA and the other one is attached to the point C. So this be C, and AC is AC is D meters, so we can call this point as C. This is D meters. You know that this much is 2 meters. The beam is modeled as a uniform rod, ropes as light inextensible strings. The tension, so the tension in the rope at C is double the tension at A. So TC is 2 TA. We have to find the value of D. So if we resolve this, it's not really going to help us, mainly because we will have 3 TAs equal to W, so it's still an expression. W doesn't really help us. So to find D, the next best option is we have to take moments. Now, I wouldn't take moments here because then I don't know what this distance is. That would be a problem. I wouldn't take moments at C because I then wouldn't know what the distance this is. So the best or the only possible way we can do this is taking moments at A. So taking moments at A, let's have a look at the forces that we have. So TA is gone because the force is going through my pivot point. Let's just use a different color to highlight my pivot point. So that's my pivot point. The next force that we have is W, and W is going in the clockwise direction. Perpendicular distance between force and the pivot point is 2 meters. So I have W times 2, and then the other force is 2 TA, which is going in the direction. So that is going in the anti-clockwise direction, and the distance between the force and the pivot point is D. So we have 2A times D. Right, we've got a problem because again we are stuck with W. So that means we will have to resolve the forces up and down. So all the forces that are going up, that is TA plus 2TA, is equal to all the forces that are going down, that is W. So I can say 3TA is W, which means I can now use that value here as W. So W is 3TA, times that by 2 is equal to 2TA times D. So TA's kind of cancel off, 2's cancel off. That means D is now equal to 3 meters. That means this distance is 3 meters, or we can say this is 1 meters and this is also 1 meter. So D is equal to 3. And that is part A. Right, moving on to part B. Now in part B, it says a small load of weight kW newtons. It says newtons. That means I'm not timesing the mass by by g's. It is just the weight, so that's kw. Is attached to the beam at B. The beam remains in, again, so that's in equilibrium, but because a new weight has been added, that means we cannot use any of the answers that we had used before. So the tension might change. The load is modeled as a particle tension. Yeah, you can see the tension is now 4 times the tension at rope A. So this is 4TA. Now, we still get to use the 1 meters or the 3 meters from the previous question because we're not changing the position. It is still attached at A and C. So the 3 meters is still the same, which is why we get to use the 1 meters that we had before. Right, we have to find the value of K. So in any moments question, because it is an equilibrium, a couple of things that we can do: resolve the forces up and down. So we now have 5TA, all the forces going up, is equal to W plus KW. So that is all the forces that are going down. We can take moments. So taking moments, the question is, where do we take moments? If I take the moments about KW, would that help me? Maybe it might help me. Okay, let's take the moment here and let's see what happens. Right, so taking moments at B, I am trying to get rid of the K. I don't know if it's a good idea, but let's see. So taking moments at B, let's highlight this in a different color. So the force KW, that is gone out of the picture, so that is gone. The next force that we know is 4TA. So that's 4TA, and the perpendicular distance between the force and the pivot point is only 1 meters, and it is going in the clockwise direction, so that is times 1. The next force that is going in the clockwise direction is TA, and the distance between that force is the entire length, which is 4 meters, so this is times 4. And the moment that is going in the anti-clockwise direction is caused by W, and then that is times the perpendicular distance, which is 2. Right, so we now have 4TA, so that's 8TA equals 2W. Does that help me? Maybe we might be able to plug in what is, yeah, so I can say 4TA is W, and then now I could use that here and say 5TA is equal to 4TA plus K times 4TA. And as you can see, we can cancel out all the TAs. So 5 is equal to 4 plus 4K. That means 4K is equal to 1, or K is equal to 1 over 4. Now I remember doing this question by taking moments at, I think it was C, but all you have to do is just make a tiny adjustment to your simulation. It's just about, setting up the simultaneous equation and then solving them to get what is K. So it's not really mandatory that you should have taken the moment. So the only reason why I did that is, we could have gotten rid of the KW so that we would then get the A, TA, and the W, which can be then nicely put back into the resolved forces. So that is part B.